Lithium ion batteries. Lithium ion batteries are dominating the battery market over a decade now. So lithium has all the properties which is required to become a most attractive anodic material for the design of battery because they are a very high density batteries. Why lithium is attractive anodic material? Because it tops the electrochemical series with the least electrode potential of minus 3.04 volts. Also, lithium is the lightest alkali metal with the equivalent weight of 6.94 grams per mole. There, and also lithium has very high thermal and electrical conductivity. Talking about the lithium ion battery, the construction. Lithium ion batteries, the anodic and the cathodic material in this battery, it is actually the intercalated compounds. The anode here, it is made up of lithium graphite intercalated compound, whereas the cathode here is made up of lithium metal oxide intercalated compound, the transition metal oxide intercalated compound. The electrolyte which is used here is hexafluorophosphate, lithium hexafluorophosphate, which is a lithium salt dissolved in the organic solvent. A separator is used, which generally preferred is polypropylene. This is what how the lithium ion battery looks like. So this is the anodic material, lithium graphite intercalated compound, and at cathode lithium metal oxide. So here the cobalt oxide is used, lithium cobalt oxide intercalated compound. A separator here and the electrolyte LiPF6. Now what is the working? So first let's see the representation. The representation of this battery. First the anodic material, lithium graphite intercalated compound, then the electrolyte LiPF6, and then the cathodic material, lithium metal oxide, cobalt oxide intercalated compound. Working, if we talk about the working of this battery, the discharging reaction, what happens during the discharging of a battery? At anode, what happens? Lithium atoms which are present in the graphite layer, that is C here, are oxidized, liberating the electrons and lithium ions. So electrons, they flow through the external circuit to cathode, and lithium ions, they flow from the organic electrolyte LiPF6 towards the cathode. So therefore the reaction LiC6 liberating the electrons, the lithium ions and the graphite. Meanwhile, at cathode during discharging, lithium ions are reduced to lithium atoms and are inserted into the layer of the metal oxide, and we end up getting the lithium metal oxide intercalated compound. So net reaction LiC6 COO2 gives you LiCOO2 plus 6 carbon. So during the charging, the reverse happens. The lithium atoms which are present in the layered structure of the metal oxide are oxidized, liberating the electrons and lithium ions. Electrons then they flow through the external circuit, and lithium ions flow through the organic electrolyte now towards the graphite carbon electrode. And then to other end, at graphite electrode, what happens during charging? Lithium ions are reduced to lithium atoms and are inserted into the layered structure of graphite, and thus the battery is now being recharged. After the working, the advantages of lithium ion battery: high energy density, long life and high cell voltage. The credit goes to lithium because of its very low electrode potential and lightweight. The applications, these days they are used in the cell phones, the batteries of the cell phones, in the laptops, also in the electrical vehicles, and there are many such applications of lithium ion battery.